Hi, this is going to be our first review session for Exam 1 for Chem 110. This would cover Chapter 1 and 2, and so I'll go over some of these problems and make sure you try similar problems. And if I were you, I'd pick problems from the book which are similar to what I'm discussing now, and that should prepare you for Exam 1. My questions will be very basic. The first question, because this is the first exam that covers only Chapter 1 and 2. First question would be on like heterogeneous, homogeneous mixture. Say for example, I have sand and water. So if you have a beaker with water and you put some sand in there, we all know the sand is going to sit at the bottom and water is going to be on the top. Whenever something like this happens, the mixture is going to be heterogeneous. So this is a heterogeneous mixture. So your question would be, if I ask you this question, what kind of mixture you get after you mix sand with water? Your answer would be heterogeneous. So what is the definition of heterogeneous? You get more than one phase. Like one phase, in this case, is sand. The second phase is water. And whenever you have a heterogeneous mixture, there will be always more than one phase. Then other kind is a homogeneous. Sugar and water. If I add sugar and water together, you all know that sugar is going to be completely soluble. So in other words, if somebody doesn't know what you mixed, that person would not even know whether there is something else in there other than water. So it would look like only water, even though sugar is also mixed there. Can I separate sugar from here? No. So in other words, you have a single phase. So one phase, but it's a mixture, and so it's a homogeneous mixture. So if you study like this, then you have no trouble in answering this question on homogeneous and heterogeneous mixture. And then there'll be a question on this. Okay. So next question is symbol of elements. I'd like you to have a periodic table when you are doing this kind of problems. Your book has periodic table on the inside cover. Otherwise, you can also get a periodic table from my lecture note, which has periodic table. You can look at periodic table at this point for your practice. You can look at periodic table and try to name these elements. So you'll have to know the symbol of the elements and their name. I'm not going to give you complicated ones, but I'd like you to know at least element number 1 through 54. And the elements beyond that, if I have assigned homework problem, then you ought to know those elements. Let's, for example, I'm going to pick one of these, say element number 54. I will give you a symbol like this and put down a lot of different names. And some of them would be right, some of them would be wrong. The right name is xenon for Xe. Okay? What would happen if I give F? Then I can ask you, what's the name of this element? That's fluorine. Make sure you know the spelling of it. F-L-U-O-R-I-N-E, which is a very common mistake. So I'd be testing you, testing the names as well as symbol for these elements. So make sure you know all these elements, 1 through 54, and beyond that, the ones that I have assigned as homework problem. Okay, next problem that I would like to go to would be the temperature scale. I'll give you 3-4 different temperatures. Say boiling temperature of water, for example. So boiling point of water. We expect that you know what is the boiling point of water or melting point of ice. So boiling point water is, in centigrade scale, is 100 degrees centigrade. Melting point is 0 degrees centigrade. But if I change the scale from centigrade to Fahrenheit to Kelvin, these numbers get changed. So what I'm going to do, I'll give you 3-4 different temperatures in different scale, and then ask you which one is the highest temperature, which one is the lowest temperature. So say for example, I'm going to write down 3 numbers here now. I'll say 0 degrees centigrade, 270 Kelvin, and say 35 degree Fahrenheit. If I give you these 3 figures and ask you which one is the lowest temperature and which one is the highest temperature, since these units are different, so you can't rush into this answer. You need to make the conversion from Fahrenheit to centigrade or from Kelvin to centigrade, and then you can compare these numbers and say which one is the highest temperature, which one is the lowest temperature. If you read the text, you'd see this kind of formula, like degree centigrade equals to 5/9 degree Fahrenheit minus 32. So whenever you're converting temperature from, say, Fahrenheit to centigrade or from centigrade to Fahrenheit, you can use this. Just to give you an understanding of it, this really comes from 100 over 180. In case you are wondering that why this 5/9 is coming, this is degree Fahrenheit minus 32. This is the 100 division of Celsius scale, and this is the 180 division of Fahrenheit scale between melting point of ice and the boiling temperature of water. So that's how they are graduated. So 100 over 180, that becomes 5/9. Anyway, you don't need to pay attention to that. You can just write down 5/9, then degree Fahrenheit minus 32. That's how you can convert from, say, Fahrenheit to centigrade. And then from Kelvin to centigrade, you can do the similar thing. It's a lot more straightforward. Degree centigrade plus 273.1 gives you Kelvin. So from Kelvin, I can go centigrade. And then we can compare. If you change all of these in degree centigrade, and then you can compare which one is the highest temperature and which one is the lowest temperature. So make sure you know, basically I'm asking you to go over these conversion from degree Fahrenheit to degree centigrade. From degree centigrade to Kelvin is straightforward, 273.1. So degree centigrade plus 273.15, or just 1 would be fine, equals to degree Kelvin. Okay. So make sure you know this kind of conversions. Then I would have straightforward questions on precision and accuracy. Many of you are doing lab experiment or have done in the past, so you probably heard about precision and accuracy. If I repeat one experiment, say 5 different times, I may not get exactly the same result. My results could be close. If my results are close, then we say that precision is pretty good. But that doesn't guarantee that my answers are right. So precision doesn't tell you how close to the right answer you got. It only tells you in repeated experiment how close were your values. Okay? On the other hand, accuracy. So you have to know the difference between accuracy and precision. Accuracy, on the other hand, tells us how close to the right answer you got. So I did an experiment and I find that I got, say my exact number should have been 2.005 and I got 2.002. So I have a pretty good accuracy because I have all these numbers right. Okay, so that's accuracy. That means how close to the right answer you got. That's the accuracy, or a true value that you got. Next, we need to know isotopes, the definition of isotopes, and also some calculations involving isotopes. Now, what is the definition of isotopes? Let me write down some of these isotopes that you'd know what isotope means, and you can come up with a definition of isotope. In my lecture note also you'd see these definitions given. When you talk about hydrogen, there are several different kinds of hydrogen. This is one of them, hydrogen with mass 1. The top number is mass number, which is basically number of protons plus neutrons. The bottom number is, we call atomic number or number of protons. Periodic table would show you elements they're organized according to number of protons. So if you look at periodic table and you look for element number 2, that means there are 2 protons in helium. Element number 2 is helium. Element number 1 is hydrogen. So this is hydrogen with 1 proton. Now there is more than one kind of hydrogen. Let me tell you what are the other kinds. This is the second kind of hydrogen. This is the third kind of hydrogen. How are they different? Or how are they similar? Or they have same number of protons. It has to be. In order to be the same element, the number of protons has to be same. But look at the top number. They're not same. This is 1, this is 2. 2 means 2 times heavier. This is 3 times heavier. But they're all hydrogens. And these are called isotopes. So now if I ask you this, that what is the definition of isotope? There are several different ways you can give the definition. Of course, I would have multiple choice type of questions, so those choices would be given. So if you understand this, you can pick the right one. But say I can say that same number of protons but different number of neutrons, or same number of protons, different mass number are the isotopes. So either way, you'd be right. Okay, so make sure you know some of these basic definitions. Then let's do a few calculations with isotope masses and the average values. So let me write down, the next would be calculation involving isotope masses and their percent abundance. Let me first give you the background before we do this problem. This is going to be our problem on isotope masses and the average mass calculation. If you look at any element given in periodic table, and if you look underneath, you'd find the mass values given. But that's not a mass of a particular isotope, rather it's an average mass of all those different isotopes for that particular element. For example, under hydrogen you get 1.008. Some books you'd have 1.0079. But that's an average over isotopes 1, 2, and 3. Hydrogen has 3 known isotopes. Okay? In the same way, you have other isotopes for other elements, and you get an average, and that's how these values are shown in periodic table. This is the value underneath each element in a periodic table. Let's do one quick calculation, and I picked 2 problems from the book for your practice. So in exam you'd have a similar problem. So make sure you practice this kind of problems. The first problem I'm going to show you, without showing you the final answer, I'd show you the setup, which would be number 71, number 35, page 71. And this is the chemistry, the central science, 12th edition. Now this question has to do with magnesium. 3 different isotopes of magnesium are given, and their percent abundance and masses are given. So what question is, what is the average atomic mass for Mg based on those isotopic masses? So let me write down first so that you understand what we're doing. So this is 2.35 magnesium. So they have given you 3 isotopes. Just to save our time and save our writing, so I'm just going to write down isotope 1, isotope 2, isotope 3. So they have given you magnesium 24, and then this 25, 26, all those. Now, the values are percent abundance. If you have a book in front of you, it's a good idea to look at it so that you know exactly what is going on here. At least you should be able to read this, read the question and understand better. So this is percent abundance is 78.99. Then this one is isotope 2 is 10.00, 10.00, and isotope 3 is 11.01. These are the percent abundance in nature, and masses are given is 28.98504. If I make a mistake, make sure you do the right thing, because when I'm doing on the board, I may make a mistake, but make sure at least you know the setup, and then you can do this calculation independently by looking at all these values given in the book. 25.98259. 259. Okay. With these values, let's calculate average atomic mass for magnesium. In case you need some clarification, let me go over this. Percent abundance means what percent of different types of magnesium exist in nature. So if you get magnesium from nature, it would have about 78.99% of one isotope of magnesium. Second isotope is about 10% with mass 24.9858. Third isotope would be about 11% with that mass. With that information given, how do I calculate average mass, which is listed in periodic table? Okay, percent abundance, they use that number first, 78.99. Since this is percent, we make a fraction, divide by 100. Okay? Now then you need to multiply that with its mass. So that means this is the fractional contribution coming from this mass to the average. So 28.98504. So that's going to be contribution from isotope 1 to the average mass. The second contribution will be coming from isotope 2. So this is isotope 1. 10.00, so 10.0, again divide by 100 to get the fractional abundance. And contribution of the mass for this fraction will be this multiplied by 24.9858. So this is the second isotope. And the third contribution is coming from the third isotope, which is 11.01 divided by 100. I guess I'm getting too close to the edge. So I think I need to write down here. Let me rewrite this. You probably can't see this. The third contribution will be coming from here, 11.01 divided by 100 times 25.98259. That's isotope 3. So I'm just showing you the setup. If I have 3 isotopes, I must have these 3 contributions coming from 3 different isotopes. Then you basically multiply and divide, and then add up all these, and then you get the average atomic mass. Okay, so this shows you from basic definitions how you, from these numbers, I mean percent abundance and mass, how you can get the average atomic mass when I have 3 isotopes. Now let's go over a little bit more challenging problem on mass calculation. So now I try to be within this limit on the board, because you can't see if I go beyond a certain limit on the board.